So thank you for the introduction. So what I want to talk about is sort of a bit of a pet project that I've been doing on the side of my research that's motivated in a sense by a sort of pet peeve. But before going into it, I want to give a disclaimer. This is not science, right? This is not a study, there's no data, this is just an idea. Hence why I call the paper a manifesto. It's a sort of intent. And what's even worse, it's not even a new idea. Other people have said things sort of to the same effect or done things to that effect in the past. But I still think it's worth saying because in a sense, to me, it feels like an obvious thing and I don't understand why it's not the thing that is done. And so I thought, I would at least write down what I thought and at least try to make a coherent argument for why we should try to do that, to see or to be in a position to test whether it actually helps. So I'll give a little bit of context. So when I was doing my PhD, my friend Fiona said, oh, you should go and volunteer with Cambridge Stimulus, which is a thing that takes sort of PG students or students and sends them to local primary schools to help. And the thing that I ended up helping with was sort of called a so-called code club at a local primary school. And in the context of that code club, what we used was the Scratch programming language and the code club curriculum. And I'll explain why these two are relevant. And so I did this, and I also had some experience with sort of other sort of educational programming languages, and I think the same conclusions apply to all of them, or at least most of them. Now, I want to talk about a problem, but maybe before that, it's worth talking about sort of things that go well. So one thing that's really great about this approach, the sort of code club approach, is that it's project-based. And so what the kids do is, or what it has them do, is write small video games in this very nice integrated development environment. And it's really integrated. You're running your game inside your IDE. And it's really empowering. Like, the kids love it. They like what they make. They think it's cool. They can show it to their friends. Their friends think that it's cool. And it's really, like, they're really gripped. And I think, in a sense, programming is the closest thing we have to magic. Like, words have literal power over matter. And I think they really experience that sort of fascination. It's like, wow, I can make it do that. So I think in that respect, it's very well. It is very good. But there's one observation we can already make, which is that these little video games, they're sort of a very specific flavor of programs. And they're typically very, very different from the programs that you and I write on a daily basis. And I'll return to that, because that's a very important point. Another thing that's really good with Code Club and Scratch is that it's pedagogical. Like, you have clear, well-explained guide that for each individual project that sort of teach the kids how to program. And they drag and drop their blocks, and there's very good explanations of why different things are needed, why different things help. Another thing that's really great is the sort of incrementality, because you can't really ask a kid to sort of drag and drop or type 100 lines of code. It's just way too much. They would give up way before that. So one thing that's really good with Code Club is that sort of instructed to write a program incrementally where even a partial program is interesting, and you sort of incrementally refine it and add things that make it more exciting. And because it's block-based programming, then there's never like a dead lump of code that doesn't run because of there's a syntax error on line 43 where there's a missing colon or something like that. The program is sort of always there and always doing something. Yet another thing that's really great is the UI, and I want to talk about that because I think it's really important, because I'm talking about this aspect that I want to improve, but I think at the end of the day the UI is like 10 times more important than any PL aspect of this. And so I remember we switched from Scratch 2 to Scratch 3, and the kids, when we changed, their minds were blown. Like, the fact that it was so much better looking for them was such a dominating factor. So, at the end of the day, I know that my contribution is, at best, very modest. But I still think it's worth thinking about it. And the final thing that's really great is there's customability, and in particular visual customability, right? The kids, they can make their video game, and you can have, I don't know, a cat chasing a mouse, but then he can decide, I don't like the mouse, I want to replace it by like a dog. And he can just do that. I don't want my cat to be orange, I want it to be green, and they can do that, and it's very easy, and it's very empowering, because they can make the changes that they want. The instructions tell them, oh, put a cat, and they can go, actually, I would rather have a hippo. And then they put a hippo, and it's like their game. And it sort of reinforces that feeling of like personal investment. And I think it's very helpful. But there's one thing that's not so great, which is, what if you want to customize not sort of the visual aspects, but the mechanics of your little video game? And then the story is not so great. And Code Club often has, for projects at the end, there's like what if you want to take it further? And then they give some suggestions that are sort of more open-ended. Like, you could try to do that, but it doesn't necessarily give you like step-by-step instructions. But what kids want to do often is they're like, I have my little base game, and I want to take it in this direction, not the one I've been told, but like, I want to tweak the mechanics somehow. And the impression I got is that often they hit a sort of expressivity wall. They have an idea of how they want to change their games, to make it do something else. And they can say it in words, they can explain it to me who's trying to help them. But the programming language doesn't really allow them to do that. And I'll explain in more detail the sort of problems that I think I've noticed. I've seen it enough times that I get the feeling that there's a pattern. And the experience is, when they hit this wall, they get very frustrated. They're like, why can't I make it do what I want? And they feel very, very unhappy and annoyed, and then they give up often, I think, in the face of this frustration. And I think that sort of looking at these problems that they encounter with my sort of programming language theory background, then I kind of get the impression that these are artificial problems. They're problems caused by the language, but they don't have to use a language that makes them face these problems. I think we can do better. And maybe what I want to sort of make a bit more precise is the way I think the problem occurs is, if you're trying to describe programming languages, this is like a broad stroke categorization. It's not a binary thing, but often you can categorize them into transformational languages, which are the languages that I guess most of us use most of the time. And this is things like Pascal, like Haskell, like whatever. And these are languages that are redesigned to take an input and turn it into an output. And Scratch and other languages use this kind of language. Scratch at the end of the day is basically Pascal plus top-level handlers for a bunch of effects. And this is the languages that we're sort of most used to. But there's another category of languages, which are so-called reactive languages. And here the idea is not so much this sort of input-output relationship, but it's more sort of dialogue between the program and its environment, where there's events coming outside, and the program sort of decides what to do and reacts to that. And there's a sort of subcategorization of that, where synchronous languages are those that are sort of very concerned with the notion of time. And my thesis is that Scratch should use a synchronous language, because I think by switching to a synchronous language, then the kids will be able to express what they want more directly, they won't get so frustrated, and so they'll be more keen to program. And I think in a sense, merely by writing this down, it's kind of obvious that there was going to be a problem, because these little video games, fundamentally, they're not turning an input into an output. They're really about reacting to either external events, like someone presses on the up arrow, or internal event, like a ball hits a wall, or something like that. And so I think to try to support this argument, I'll give you sort of informal ideas of the kind of problems that I got the impression that the children faced, and then explain why I think synchronous languages solve this. So the first thing that children want to do quite often, and this is a thing that's very sort of natural from sort of both the video games that they know, but also everyday life, is this idea of level or phase, right? So, video game has levels. So you could have a very simple video game where you have like a cat and a mouse, and you have code for the cat and code for the mouse, and then the code for the cat sort of makes the cat move towards the mouse, and you, by moving your cursor with your physical computer mouse, you decide where the mouse, the sprite on the screen goes, right? And you can imagine you run that until the cat touches the mouse, and maybe you have a timer telling you how long you've evaded the cat, right? But one thing that kids often want to do is sort of, okay, well, I want to do a level, I want, when the cat catches the mouse, then we do something else. So for example, maybe they reverse role, maybe now the mouse chases the cat, something like that. And this is a notion that they're very used to, both from video games, I think they can express what a level is, but also from everyday life, They know that when they're at school, they're supposed to listen to the teacher, and then like the school day ends, and then they go on the playground. So there's this idea of a phase, like a division of time, is a thing that they know and that they can express in words. How do you express that in sort of Pascal plus top-level event handlers? Well, it's easy. You just add a turn variable, and then turn can be 0 or 1. And then, if turn is 0, then you do the code for the first part, and if turn is 1, then you do the code for the second part, and then somewhere you have some increment of that turn. This works. It's absolute spaghetti code. It's code that I don't want to write, but I can write it because I sort of have the mental model of, at the end of the day, this is just an automaton. I know automata theory. I can just, encode it. I can think of my program, as a transformational program, as like a function that takes the previous state and the action and determines the next state, right? And if you program like Arduinos or whatever, this is the normal way of programming these things. But the thing that allows me to do that is this mental framework that I have, as an adult, and also sort of, in a sense, the patience to go through this extremely painful encoding. And then not only is it painful to do, it's also painful to maintain. And also, when you're doing that transformation, your code is basically, in a sense, not compiling. Of course, it still runs, but it's like it's behaving weirdly and incomprehensibly, and the structure of the program really doesn't help you. And my point is, this is like absolutely not necessary, right? The language forces you to do that, but we all know programming languages well enough to say, well, you can obviously have in your language a way to sequence concurrency. So you can have, the cat chasing concurrently with the mouse fleeing, and then when they're done, the cat fleeing followed by the mouse chasing. I've written it down using syntax that you all know, right? Why do we deny that to the children? They need even more support than we do. I can write these automata. I don't want to, but I can. They're really much more powerless in that respect. So that's a first aspect, I think one of the first two major aspects. The second major aspect is preemption. And again, when you say it with a fancy word like that, it sounds very technical, but the idea of, you do something until someone tells you to stop, this is a very fundamental idea that the children are intimately familiar with, right? And so the problem that they might encounter to do with preemption is this idea of, well, maybe you're repeating until the cat reaches a mouse, you want your cat to move. So how does a cat move? I guess a cat moves by moving the front left leg, then the right back leg, then the front right leg, then the back left leg, right? And this is 4 steps. But if you write it like this, in a sort of transformational language, then this doesn't stop as soon as it should. If the cat reaches the mouse here, it'll still move 3 times more before stopping. So there's something that's like kind of annoying there. And of course, as you well know, you can write spaghetti code that avoids this. Again, I can do that. You can do that. None of us want to do that, and the children, it's just too much, right? They'll do it wrong, they'll get fed up. And not only is it spaghetti code, but also it completely kills any form of modularity. Like if you have code that wasn't written to be preempted, you can't preempt it in these languages. You have to go and edit that code and basically edit every single line. And if a child says, oh, but I want my cat to stop immediately, and you tell them, oh, it's easy, just write this, they look at you and they go like, what is wrong with you? I mean, there's really this sort of like, this loss of respect, like, why are you giving me this stupid programming language? Like, why is programming so stupid? I can say in words what I want to see happen. Why can't the language do that? And the answer is, well, obviously the language can do that if you use the right language, right? So you can have a language with first-class preemption. And you can introduce what some languages call a trap, and then you have your code here that moves the cat limb one by one, and then as soon as the cat touches the mouse, you just sort of suspend that computation. Wherever inside of this it was, you just immediately stop. And this, again, it's a concept that the children understand. It's a concept that the children can express, but the language denies it to them. So these are the big two concerns, I think. There's a bunch of other things. One of them is sort of loosely described as user-defined signals. So often when you write a program, you might have like a sprite, I don't know, a cat that does something, and then a mouse that does something, and then you want to sort of link them. You know, maybe when the cat touches something, it should do something, and then the mouse, as soon as the cat touches that thing, it should also start doing something. So you sort of you want to have some communication between these two things. And again, this is a very natural notion. Children are used to being told things by people and doing them, or telling people to do things and the people do it. How do you do that in some transformational language? Well, obviously, you just write shared memory concurrency. I mean, how hard can that be, right? I mean, it's not like, most of my research career is centered around the fact that shared memory concurrency is just outrageously difficult even for experts. I mean, when you show this, like sort of message passing by hand to a school child, they're just like baffled. Like, how can this be the solution to my problem? And then, I mean, there's no hope that they can maintain this kind of program. I mean, if you show them a simple example, they might be able to copy it in their own program. But typically, you have to insert that in their program, and then as soon as they want to change anything, they have no idea what's going on. Again, first-class signals. That's a thing. I can give you some syntax for it. I can give you some semantics for it. You can define signals. You can test for presence of signals, and you can emit signals. It's clean. Plus, it supports scoping. So you can define your interaction between your things, and then sort of forget about this interaction from the outside. So it's kind of clean and modular and nice. It also means that sort of these events, they don't have to be just at the top level anymore. So it's more flexible, cleaner, and honestly much simpler. And the final thing that is sort of sore point is time. And this is a bit more of a sort of implicit problem, which is these languages often, or almost always, don't have a proper notion of time, where they have a sort of implicit notion of time. So you might imagine you might want to move an object 10 times, and you might want to do that in two ways. You might want to move it 10 times in one go, or you might want it to move 10 times, one step, then wait a little bit, then one step, then wait a little bit, and so on and so forth. And so you need to decide sort of where in your language steps of time are taken. And typically these languages sort of do that implicitly. And often they do that at the boundary between sort of sequential composition in loops. So they will say something like, if you put move right by 3 10 times, then that will take sort of 10 frames, 10 30th of a second or something like that. Whereas if you put it in a loop, then it means you sort of do it instantly 10 times, right? From one frame to the next, you've moved 10 times. Now, of course, different languages sort of pick different trade-offs, but at the end of the day, I think sort of if your language doesn't have a way to talk about time, then there is no right choice, right? If time is implicit, then you do this sort of hope for the best programming. So your language might say, if you sequence it 10 times, it's not the same as repeating it 10 times, in which case it will be annoying in some cases and okay in some others. Or you might say, well, they are equal, in which case it will be annoying in some other cases and nice in some other cases. But it's not only is it bad because it leads to counterintuitive results, but it's also confusing, especially when you're trying to teach loops, and the loop is not a sequential composition of the number of times the loop is taken. Like this is super baffling, right? If you can't express loops in terms of simpler things, then it's just very confusing. Again, does it have to be like that? Well, no. We can have first-class time. I can add a pause instruction to my language, and then I have a very specific way of saying when these steps of time should be taken. Now you might ask, wouldn't that be super annoying to have to put pauses everywhere? And the answer is, well, I don't think so, because you can infer it in most cases. So for example, if you have an infinite loop, then it's pretty clear that there should be a pause somewhere inside the loop. You may as well put it at the end, right? And one of the things that's nice is with these IDE for kids, right? You can just insert the pause instruction in the right place, and then if they want to put the pause somewhere else, then they can put an explicit pause, and then you don't infer it anymore, and you just follow what they say. Right, so I've proposed syntax for all of these things. Sort of, it looks imaginary, right? So what I've proposed is sort of a language that takes sequential composition of concurrency, preemption, signaling, and time seriously. And these languages, they already exist, right? This is, from the 80s and the 90s, there's been a bunch of those. One that I've stolen the syntax of is Esterel. And in a sense, I've already described Esterel to you, but I can give you a sort of one-slide summary. It was designed for control systems, like a robot arm that does something in a factory. That was the aim. But if you think about it, it's kind of the same programs that the children write. It's sort of programs that don't do very complicated computations, but that really are centered around reacting to both external and internal events. And so, you can have sequential composition, you can have concurrent composition, you have loops, you have explicit pauses, which are different from doing nothing, and then you have signals that you can emit and test for the presence of, and you have traps that you can exit to do immediate preemption. And then on top of this kernel, you can, and people have, defined a ton of syntactic sugar to make sort of writing these things more nicely. And so what I've done is basically I've taken Esterel and I've shoved it into Scratch, and the result I've called reactive Scratch, and it's basically, I've stolen the interface and I've just replaced sort of the execution engine in the middle, and I've added sort of the primitives that I want. So in particular, this pink color is for preemption, so I have my trap and my exit to trap that I use here in, I think, this small program that I don't remember what it is. Oh, when you press the space key, then the cat stops spinning. Something like that. And here it uses the composition of sequential composition of concurrency, of signals, and of traps to very directly express a program that would be kind of annoying to write otherwise. So that's great. Are we done? Well, not really. It's still a hypothesis, right? For me, as a PL person, this feels like a better language. It feels like a better fit. It feels like the kids should not get blocked in these ways. But maybe there's other factors that I don't understand or I didn't take into account that just mean that it doesn't really make a difference. I think another thing that's not so clear and that really needs to be driven by sort of experimentation is it's clear what to expose, sort of these primitives. It's not clear how to expose them, sort of what the surface language should be in order to be understandable by the children. So for example, Esterel in fact has a whole bunch of syntactic sugar around traps so that you can define things in a sort of understandable way, because traps are a little bit counterintuitive if you do weird corner cases. And the final question is, even if you have this, how do you teach it? And this involves both developing a curriculum, but also having the people running these code clubs be able to program fluently in these languages. Whereas, I guess if it's Scratch, then it's close enough to Python that there's like millions of people who speak it. And before concluding, I'd like to make a small aside, which I think is also important, which is, I think PL theory can help a lot with children learning how to program. And a sort of silly example of that is, it's well established that rapid error feedback is one of the pillars of learning. The way you learn effectively is whenever you do something wrong, you're told very fast so that a brain can adapt very quickly. And this sort of feedback loop is very important for effective learning. Now, school children typically write very small programs. I mean, they fit on a screen, right? Otherwise, it's too big for them and they kind of give up. And so lots of static analyses that could be used to analyze these programs, but that are classically seen as sort of intractable because they have some exponential blow up or whatever, they become tractable because the programs are so small. O of 2 to the n is the same as O of 1 when n is equal to 1. So all of these things that we think are usually too expensive, we can just run them. It's fine if it takes 3 seconds if it helps the child learn, right? So really, we need to move away from sort of efficiency of these static analyses and towards understandability and actionability. I think if you tell a child, like, no, your program is incorrect, deal with it, they're not going to take it well. If you tell them, oh, you should fix this, then they'll be much more likely to listen to you. So I think really we can do a lot to help in that direction. So to conclude, just to give a quick summary, right, I think that with the current languages that are being used to teach programming, children really hit this expressivity wall. And I think it's caused by the language. And I think we can alleviate this by moving to synchronous imperative languages like Esterel. And if you're interested in talking about this, then I'm very keen on hearing your thoughts. And before I finish, I would like to thank the people who made this possible, both Cambridge Stimulus, which was this thing to get students to help in schools, and to the school children and the teachers at the school where I helped. Thank you.
So I'm curious how you're going to think about evaluating like some of the hypotheses that are kind of implicit in the proposal here. Because like one thing I've encountered when using Scratch with kids is that things that I want as a programmer are often like destructive to their ability to operate in the system. So I think a good example is I really like variables in like the scheme sense of what a variable is. That's not what Scratch has. It has global mutable state. But like trying to get a 7-year-old to program, it's much easier for them to understand global mutable state than it is to understand the kind of notion of a variable as it shows up either in algebra or in a programming language like Scheme. And a lot of the things that you're proposing here that are like, things like scope and, all sorts of things are like, in some ways, like really easy for grown-up programmers to think about, or maybe really hard for kids to think about at different ages. I'm curious both like, how do you want to go about like evaluating whether or not these things are improvements? And then also, you have any notion of like, changing the language as kids grow up and go through stages? Like the thing that is good for a 12-year-old and the thing that's good for a 7-year-old are maybe pretty different language designs. And so, I don't know, how do you think about all that?
I guess the answer is, it's a good question, meaning I don't know the answer, but I can tell you what I gave this big disclaimer because, as you said, these things that to me might seem like the solution, I acknowledge that, if you do sort of anything to do with humans, then things can act in very counterintuitive ways. And so this thing that I think might help might actually hinder. I think the only way is to test. Like, I think, like in anything in medicine, like, or, anything to do with humans, you just have to test. There's no way to sort of sit down and scratch your head and know. I think for scope and things like that, we can, I suspect, and again this would have to be tested, that we can come up with representations that sort of make them more palatable to children. Because in a sense, like Scratch and other languages, they're still very much prisoner of this sort of textual nature of programs. It's written and read top down. I think, for example, concurrency is not a top-down thing, right? So you want to sort of have another dimension and exploit that other dimension. And again, you have a scope. You can have something like a bag that contains, the scope, or that conveys it in a visual way that they understand, rather than through this indirection, through textual order or something like that. I think also evaluating all of these things is very difficult because there's so many confounding factors. One of the things that stopped me from evaluating it is I wrote a prototype, but the prototype is slow. And the fact that it's slow means that if you do a head-to-head comparison, it's just completely impossible. I think another thing is just like visual appearance matters so much. Like if you get it polished visually, then it's going to dominate any other factor. And so I guess the answer is I don't know how to do good tests for this, and in a sense, I'm not the right person. I'm a PL person. This is why I want to talk to other people who know how to do these things. So I hope I have very unsatisfactorily answered your questions.
Thanks.
Yeah, just a small question. I was interested in the jargon for the reactive primitives, particularly like a word like trap. I was thinking as a kid, if I was trying to make games, I saw a word like trap, I thought, oh great, I can trap my character and if he'll fall in a hole or something. So have you given any thought to what you might need to rename the primitives to?
Yes, I have thought about it a little bit, and in fact I do point out that trap is not great in the paper, because if you have a mouse and a cat and a trap, then it's pretty obvious there's going to be some cheese as well somewhere. Yeah, I think that, again, they sort of, as grown-up programmers, we would never think about these things for ourselves, right? But when you're designing these things for kids, you really need to think, like, how do you present these things in the right way? And then it's also culturally dependent, which is annoying. I mean, you might design your thing in English and be, okay, I'm done, and then someone translates it to some other language, and suddenly it's very confusing for reasons that have nothing to do with the language itself. If you think in terms of ASTs, but the kids don't, right? So, yeah, I think it's something that we need to pay attention to.
Thanks.
Hi, Jean. Thanks for a great talk. It says a lot about my brain, I think, but when you were going through your list of, here, we would like to have parallel composition, or we'd like to have message passing, I was thinking, what this really means is the kids need to learn about operating systems, not just programming languages. So is the set of primitives that you want to add, is there a good match with a traditional operating system and processes and so on?
I'll go out on a leg and say no. Because I think many of the primitives as they are exposed right now are they really rely on the fact that the programmer has a sort of richer mental model that they can rely on. So for example, this idea of like having concurrent composition as a primitive, you could imagine using like fork and join and things like that. And it would be a little bit more flexible, but it's also, I think, much more difficult to understand. The opportunities to shoot yourself in the foot just increase. So I think it's not just about increasing the expressivity, it's also about restricting the expressivity. And as a sort of digression, I think, for example, one way to write these programs is using functional reactive programming. You can embed all of this inside of a functional language. I don't think that's the solution for children. They'll get so confused. Like this extra expressivity will just hinder them more than anything else. And I think in the same way, you want to really limit how many things they need to think about, to learn about. If that makes sense.
It does, yeah. I suppose I don't know enough about Esterel to know that set of things is the right set of things. I should probably
Neither do I.
Well, I should read your paper, though, because that will make it clearer. So, thank you.
Thanks for the talk. It was very interesting. I was wondering if maybe, I guess maybe the way that you're thinking about Scratch as a language is maybe opposite to what the original designers were thinking, or what I imagined that they were thinking. So I guess when I think of Scratch, I think of it more as a tool to teach how imperative programming works, right? As opposed to a way to teach children how to make games. if that sort of makes sense, right? So the reason why they sort of have these things with like if statements, loops and stuff is because they want to teach children about if statements and loops and those sorts of things. So I happen to agree that I think it would actually be better if we taught them other things instead of imperative languages, but I'm quite biased because I'm a functional programmer and I prefer if they did something else and didn't get their brains poisoned by this imperative nonsense. But what is your sort of thinking about what do you want to be teaching the children, right? Is it, or what is the goal, like the intended learning outcome of these of this thing, as opposed to just what's the best way to sort of program these games?
Yeah. Again, this is a good question because I don't know the answer.
Sure.
I think there's part of the question is sort of how do you lure them in and how do you keep them in programming? And I think the thing that motivated me is really this feeling of like disappointment that I saw time and time again, and that I attributed to the problems caused by the language.
I think you're right on that, by the way.
Now, of course, there's a trade-off, right? I mean, if you keep them longer, but with a language that's maybe less connected to also languages that they might see in the future, then maybe that sort of aspect dominates the benefit that you get by keeping them more interested or less frustrated. I don't know. I think it's really a thing where you have to look at do some studies and look at the actual trade-off and see where does it cut off.
Great.
I don't think I can sit at my desk and decide.
Right. Yeah. Of course. No, I'd be very interested to see those results. So thank you.
This will be characteristically ill-formed. I tried it for a moment there, and I had to push run, in order to try my program. And I wonder if that's a mistake, because you might want to take away the capacity for the child to write code and not run it, if you see what I mean. If you hit some of your notions of compositionality and having fragments run in, without being complete well enough, you needn't ask them to run it. You could just run it anyway, if you see what I mean.
Yes. In that respect, I think I was a little bit bound by two things. A, the way Scratch itself works, and B, the fact that I already spent way too much time on this prototype. So Scratch does have this ability of sort of live edit your code. I did not have time to replicate that kind of functionality. And it's also, I think it's a bit more complicated to do that in the context of a language like Esterel than Pascal-like language where you sort of have your program counter and you...
If you can force the feedback of the change and then seeing what that does, it seems very powerful. Yeah.
Hello, thank you. My question might be the same, but in different words. Right, so I think the characteristic of Scratch that everyone knows is the kind of block-based syntactic editing and the idea of sort of locking the blocks together to form a sequence of actions. So do you think maybe there's a different user-friendly mode for expressing your programs for these richer semantics that you're proposing?
I don't know. When I think about a program, I think about the AST. Like I never think, people always get obsessed about, they talk about programming languages and they're like, oh, I don't like Haskell because it uses white space indentation. And to me, that's just a bizarre statement to make. For me, I really think about the AST and whether it uses curly braces or space or whatever, it's all the same to me. And so there's this whole area of how do you actually make a language that people like to use, and I don't know the answer because I never think about it.
Respectfully, syntax is what hits the novice programmer. And, we forget that.
So I think one thing that I mentioned that I did think about is sort of, I think concurrency should be horizontal in the same way that sequential composition is vertical.
That's nice.
I think block-based is very good because it maintains this property that your program is never syntactically ill-formed until you have variables, in which case weird things happen.
Okay.
I think there's a lot of space there for improvement, but I'm maybe not the right person to ask.
Right. Okay. Well, thank you very much for a very interesting talk.
Okay. Hi. Yeah, one question. Are you aware of Haiti and the research
Yes.
around? Okay. All right.
Yes.
And related to that, I think I was wondering if you have thought about the gradual introduction of these features. As in, I imagine the kids at some point they face this wall, and then maybe you could do some like analysis to pick out the features that you have here to suggest them in a way. It's like, hey, maybe you could use this for solving your problem.
Yes, I think this is. I mean, in a sense, the Code Club curriculum kind of already does that. There's sort of, a simple project, slightly more complicated project, and you sort of use features incrementally. I think the idea of sort of revealing the language incrementally is, and also, which are the things that you should introduce first, is very important. I think that a language like Esterel, like the way it's defined, is really the surface language, is just syntactic sugar for the sort of this very, very small core. And I think there's really a whole design space that needs to be explored about what are the right primitives to start from so that you can then refine them in terms of sort of the kernel language itself that you might use as an expert. This is the extent of my thinking. I don't know how exactly you would do that. But I think it's important. Yeah.
Okay, thank you.
All right, so